By far the most powerful way to solve simultaneous equations is Gaussian elimination. So let's talk about that. If I have the system five x1 4x2 plus 3x3 plus 9x4 equals 49. So let's say we have this system here. First thing we do in Gaussian elimination is solve for x1 in the first equation. So if we do that, x1, bring everything over to the right-hand side and divide by 5. And now we substitute 2 into 1. For the remaining equations. So we'll get 3 times x1, which is this, plus 2x2 plus x3 plus 2x4 equals 19, minus 14 times all this meaning 9.8 minus 0.8 x2 and so on. And then finally, 12 times all this. Plus 6x2 minus 25x3 plus 10x4 equals minus 38. Okay. Now if we simplify all this, we get minus 0.4 x2 minus 0.8 x3 minus 3.4 x4 equals minus 10.4, 3.2 x2 plus 1.4 x3 plus 30.2 x4 equals 69.2. And finally, the last equation, 3.6 x2 minus 32.2 x3 minus 11.6 x4 equals minus 155.6. Let's call this set of equations equation 3. Now, the first set of equations, 1, is equivalent to this equation for x1 and this equation for the x2, x3, and x4. So 1 is equivalent to 2 and 3. Now, since x1 doesn't appear in this set of equations, we say it's been eliminated. So what's to do next? We want to eliminate x2. We've eliminated x1, now eliminate x2. So in this set of equations, solve for x2. Right here up top, x2. If I divide by 0.4, bring everything to the right-hand side, divide by minus 0.4. 26 minus 2x3 minus 8.5 x4. All right, let's call that equation 4. And now substitute equation 4 into 3 for the rest of the equations. All right, so we do that, we get plugging in equation 4 into here, we finally get minus 5x3 plus 3x4 equals minus 14 minus 25x3 plus 19x4 equals minus 62. Call that a set of equations 5. All right, down to the home stretch. Now we eliminate x3. So bring everything over to the right-hand side, divide by minus 5. x3 equals 2.8 plus 0.6 x4. This is equation 6. You get the pattern now. We substitute 6 into the final equation in 5. And we get 4x4 equals 8. And now we got x4 equals 2. So that's equation 7, and that's equation 8. Now we're done, because now we can back substitute. So we back substitute equation 8 into equation 6 to get what we want for x3, because now x4 is 2, plug that in there, now we get x3. x3 equals 4. All right, now we can back substitute that. Both x3 and x4 into equation 4 to get x2. So basically we're taking equation 8, well, this is equation 8, this is equation 9, and substituting it into equation 4. And then we get x2 equals 1. One more time, back substitute. Equation 10 for x2, equation 9 for x3, equation 8 for x4, and substitute that into equation 2 for x1. And we get x1 equals 3. And we're done.